Hello everyone. In today's video we're going to implement C's strStr method. And this is LeetCode problem 28. So the problem starts by saying implement strStr. Return the index of the first occurrence of needle in haystack. Or -1 if needle is not part of haystack. So basically C has a method called string or strStr, which is basically substring. It'll find the string value of needle in haystack. Now, there's another exception where needle is an empty string, so that's specifically this case, and in that case we're going to assign it to 0. This is consistent with C's str method and Java's index. Because we're doing this in Java, we're basically implementing the indexOf method. Instead of calling, whatever string value indexOf, we're going to implement what the code that actually runs when you call the indexOf method. So let's look at some examples. The first example, haystack, is hello, and needle is LL. So the output is 2. So if you take the position, start at 0 here, then you do 1, 2. So LL starts at position 2. Example 2, you have haystack equals and needle equals ba or BBA. Output is -1 because in no place in haystack does BBA exist. And in the last example, both haystack and needle are empty strings, and so the output is 0. Alright, so let's start by pseudocoding this. So LeetCode gives us the method passing in 2 strings. We need to handle all those null exceptions, or if the needle length is greater than the haystack length. Anything of this nature is just going to be -1. We need to handle the specific situation if needle is the empty string. So basically we're going to loop through haystack length minus needle length, and I'll explain that why we're using haystack length minus needle length. So if the haystack contains the needle, then we return the starting position of needle in haystack. And that's pretty much it. End the statement, end the loop, and return -1 if you don't find needle in haystack, and end the method. Alright, a few things to talk about. How do we determine if needle is in haystack? So we're going to use what's called the starts with method. So the value inside haystack, if that starts with hay, let's say haystack is actually the string value haystack. So then that will return true. Now, the problem is that only works when it's position 0, because that starts with the entire string there. So if you did haystack starts with stack, it's going to return false. So what do we do here? So we're going to do starts with also has another method, or has another parameter that you can add called the offset. So you can pick where you want it to start to search. So basically if we did haystack starts with stack at position 3, so haystack 1 to position 3, well, yes, then haystack, or the haystack starts with stack at that position. Okay, another thing we need to discuss is why do we iterate through haystack length minus needle length? So let's say we have string haystack that equals haystack, and we have string needle that equals needle. So haystack is 8 characters, and needle is 6 characters. So let's say we start at H. It's not in haystack, it's not in, so this will start at A, it's not in AY stack, not in Y stack. So when we get past the Y, there's only 5 characters left. But needle is 6 characters. There's no way you can stuff 6 characters into 5 characters. So we don't even need to check these last 5 characters. Now you can do it. It's just extra overhead that you don't need and not quite as efficient. So in an interview, if you had to code this, it would look better to do haystack length minus needle length. Alright, so let's code it. So this, again, is the method that LeetCode gives us. So if haystack equals null, or needle equals null, or needle length is greater than haystack length, then we're going to return that -1. Now, if needle length equals 0, then we're going to return the 0. And that pretty much takes care of all the exceptions. So we're going to start to iterate through the haystack, setting I equal to 0, less than or equal to the haystack length minus needle length, which we talked about. Okay, so if haystack starts with needle at position I, so in the first time through this, it's going to start at position 0. And if that's true, then it's going to return I. Otherwise, it's going to go back, and now I will be 1. And so it'll basically remove the H and start at the A here to see if it exists. And we'll loop through that, and if it never finds it, then we'll just return -1. And that's it. All right, so let's debug this and see what we get. So I've used the example that LeetCode gave us, the first one, with hello, and we're looking for LL in hello. If I start out here, it basically passes all the exception checks. So now we're going to get into the for loop. So if haystack starts with needle at position 0, well, needle is LL, and hello does not start with LL, so it's going to bypass that and go to the second loop, or second iteration. This is also false because now we've removed the H and we're just doing ELLO, and the ELLO does not start with LL. But on this pass, we're actually now at past the E here, so we have LLO, and LLO starts with LL. So we're just going to return the position, the current value of I, which is the position that LL starts. And that is it. Result is 2. Alright, so let's run this through LeetCode. Run the code here. Fingers crossed. Works great. Submit this. Faster than 59%. Not bad, not bad. And uses less memory than 85%. Well, that's pretty good. Alright, so the last thing I want to do is go through the time and space complexity. So the time it takes for running an application. This is O of n. Basically, as you increase the size of haystack and the size of needle, it's going to take longer. And then the space complexity is the same. It doesn't matter. There's nothing in the code that's going to increase the size of haystack or needle. They're set size throughout the entire code segment. So, and that's it. As always, let me know if you have questions. Thanks for watching, and good luck on your interviews. We'll see you next time.